Where is the following function discontinuous? Now, discontinuous means if I were to trace, is there any point where I would have to lift up my pen because I have to make a hole, or maybe there's an asymptote, or maybe there's some type of break in the graph? Well, I see a few spots that that's going to happen. If I were to start from the very left, I'm going down this nice little hill, it's concave up, but at no point do I have a hole up until I hit value 2. Now at 2, I have no value. It's a hole, and in fact, there's no value that if I were to plug in for what looks like 3.5, I actually get something. So 2 is what's called a point of discontinuity because there's nothing there. If I keep going to 3, I have another break. Now you might be thinking, all right, at 3 here, if I were to plug in a value for 5, it looks like I get 1. Does that mean it's not a point of discontinuity? Does that mean it's continuous? No. Since this is a hole, it still is a break in my graph. Even though there's a value down there, there's still a break in my graph, which means at 3, it is also discontinuous. So there's two places where this graph is discontinuous, at 2 and at 3. 1 is fine. I don't care that this is weird concave up to concave up action. But 3 and 2 have holes in them, and since they're not filled in, it's not continuous.